Okay, everybody, thanks for waiting. We are in the workflows group. There was an important eureka moment yesterday that we are going to present to you guys. I'm Thiago from Trimble SketchUp, then we have Michelangelo from Akka. And yeah, we have a successful exchange between two softwares using IFC5. So, woo. From the SketchUp side, we relied on our good friend, Jan Brouwer, that develops the IFC exporter manager. And he was able to grab the data from SketchUp model, and then we sent to Akka. And Michelangelo will also explain a little bit more in the open house. You want to say something?
No, I mean, don't want to take time, but maybe we can go more into the details after in the open house presentation.
Yeah, so basically what happens here, an important achievement is the ability to record some moments. So we have, for the history of buildingSMART, on when the exactly moment where we were just exporting the data and then Akka was reading and then things were popping up and we were finally able to see like the names, the property sets, like everything was recorded there. So we can later exchange the file, and I don't know how we are going to do this, Leon, but we can exchange the data there. This is part of the exchange workflow that we were discussing, and then there was a lot of discussions on what is the schema definition and what is like the role of implementers. I'm not going into details here, but it was quite a fun discussion to have. And another thing that we had, it was a discussion about headers, how to identify the files and what we can do if, as long as we identify the layers. So we have a first proposition on 9 or 8 things that we think it's important to identify. So we have like a layer hash, organization, the software, the version of the software, a timestamp, the author. Then we can like discuss like if an email is sufficient, or do we need the names or any other data there. The preprocessor version, like in our case at Trimble, we have like a Trimble converter, but if you are using ODA, you can have like ODA there. Schema identifiers like IFC5. I don't know if you are ever going to have IFC 5.1, 2.3, but yeah, this is the how we were implementing and testing. So it goes in the top of the file, these identifications. The layer hash is quite I call it, it's a thing or layer hash, but it's a URL, like a file location. Then you have an at. We can use like a ISO 19650 state, whip, share it, publish, and then a thing grid, like a layer grid that you can use to make queries for that specific file or layer or thing. When we put everything together, like we can create, this is like a composition file where we can save the URL and the signature. Like for if Evandro wants to check if the data was modified or not, like you can create a hash for that using SHA-254 and then sign and register that in this file, making a composition. And what happens in this workflow is every time that you are data streaming or if you are creating a file in this composition, you can go and start registering this every time. And the fun part of this is that we can query this kind of stuff, creating like some Python scripts. And this is, just imagine like, and because this is a workflow that's quite difficult to do today, if you want to, without a CDE or this kind of stuff, if you want to have a picture of your project current state, you can easily track, use the URL, like the codification that we created, And I want to know like how many files are in WIP, how many files are in shared, how many files are in the published state. And also, another thing that we can carry is about like, I want to go over my composition and identify using like, oh, this is the code or the hash or the block hash that I have for that layer. And I want to know like what is the quantity takeoff for that specific part. And you can do that really easy, actually. So we are just tracking what are the columns and the instance of that columns, like what's happening inside the file. And then with properties and attributes, we can just start to do more cool stuff over here. So in the end, like this is what we have. It was a fun hackathon for us. So I have lots of learnings. I don't know if questions is now or just present and go.
Questions now, less burning questions later.
Okay. Yep.
Thanks so much.
Thank you.
All right. So Michelangelo and I did the first thing I'm going to talk, I've got two, so I'll talk first about non-destructive editing, which is apparently a controversial word. We can take a poll afterwards if this should be called editing or not. So what we do here is we can browse for a file. I'm going to grab the hello wall.ifcx. It's great. And what we've done, instead of either doing an implementation in one of the authoring software, this is our custom built for the hackathon BIM software, a table. And we've just got a list of all these values, and we can actually edit the values of these properties. So we're not going to win any awards for our BIM software and the UX, but we're going to take this void, and we're going to change its property from visible to invisible. And if we scroll down, we've got a list of all the edits. And I want to download my changes as an IFCX file. So I'm going to go download edits. So it does all that. And I can download the IFC file. And so this is giving me hello wall edits 2. So if I go to the viewer, I've got hello wall here. OK, that's great. And I'm going to browse for the file I just created, hello wall edits 2. And I'm going to add that. And in the order, none of my edits are being applied because they're at the bottom. So if I switch that to the top, you can see that the voids through the walls all of a sudden have appeared. And for the sake of completeness, I can open the file. You can see what it looks like. Open with Notepad. So this edits file is real simple. It's 1 over, and it's updated the attribute visibility from invisible to visible. So this is a very proof of concept of opening an IFC file into a BIM editor, making a change, and the BIM editor is keeping track of just my changes, and it's writing out the changes to a second file. And then in the BIM viewer, in the IFC5 viewer, we're able to then compose the original plus the edits and get the edited version. And it's really clear who the author of the edits are. That's in one layer, in one file, and then the original file is somewhere else. So this could be something like structural engineer. This is my background. Sends a model to the architect. Architect's like, move your columns. And they send back a layer where they've moved the columns. They haven't modified my file, but they've communicated very clearly with me where they want those columns to be. And then I can handle that either with change management or by hand or something like that. Questions? Yes.
So, hypothetical. Is the intention then that you would have an infinite list of these, or would there be some intention that every so often you'd collapse this? Or?
I think the tool permits either. There's sort of different use cases. It may be, so maybe there's one use case where one of the edits is the acoustic engineer adding STC ratings to a wall, and they're publishing their edits. And what they may do is they may update their edits file. So rather than having 15 and they keep adding edits to it, they, they open the old file, open their file, and then they can modify their file. So it's like a versioned, like we had in the previous presentation, a versioned one. You might also get the outcome of a coordination meeting. You might have ephemeral ones where someone sends it, and the intention is like, they could even just send an email with this file and be like, hey, this is what I'm talking about. Here's a suggestion. And the intention is for that file to never be used again. So I think in my imagination of the future, you've typically got, you don't have an unbounded growing set of these things. You're not using these things to track the history. Each author is tracking the history of their file. But you have this capacity to compose, and you can do one-off extras. You could just keep all your edits as overs and then collapse them periodically.
Attach them to BCF issues.
Well, that's next.
All right.
Maybe a question for the group. Should it be a tree? Because that's what USD is, right? USD has sublayers, and that's how you build a tree of layers. And we chose for a flat list for simplicity, but maybe that simplicity also becomes complexity when you have too many of them. Is there
Yeah.
anybody who has an opinion?
I think this works with a tree or not a tree.
Yeah, but
Yeah.
IFC5 currently doesn't have this notion of sublayers.
Right.
Just one common reflection. This looks more and more like a code repository.
Maybe.
Every over is an edit of the code file, source code file. So maybe get inspired by
Yeah.
code repositories.
Another way to look, there's two aspects of the code repository. One is storing the history and storing the changes, right? And Git actually stores the current version, and then when they pack it, they like back calculate the diffs, but that's another story. You also have in your like requirements text or in your NPM packages, you have references to a bunch of other stuff and other versions. And so those two things are both useful to think about. I think the overs are closer to the references to other versioned packages, where you're pulling those in, and then together it becomes the whole software that runs, right? Your imported packages and then your own package.
We also have the concept of baseline that in a way take a thread through all revisions, and you can work further on with new revisions, but this baseline is maybe something you deploy. That could also be some way of have formal versions of the IFC model, even though we work further on with it. Maybe.
Yes, I feel like that's going back to the header question, right? You have, I can compose the published versions of everyone's files, or I can compose the WIP versions of everyone's files. And the published version is to, issue for construction or to issue for approval. And the WIP version is for the coordination meeting. We want to see what's everybody's latest. Are we going in the right direction, kind of thing. But in my mind, that's independent of the over. There's like, we're composing a bunch of different things, and those things are each versioned, however they happen to be versioned. All right, I will continue. Okay, so the next one is over here. So this is BCF. So I've created, again, the world's worst issue tracker. So if we create a new, well, I won't go through it. You can do some things. Every time you hit create issue, it adds it to the list of issues. And then we can download the issues in an IFCX file. So here, it downloaded a new file. It's IFCX. What does that mean? So I'm going to come over here and just load that in to the model. Nothing's happened visually, but if I scroll to the bottom of my tree, I have to click. There we go. If I scroll to the bottom of the tree, I now have a list of open issues. And if I click on each issue, I can see that, there's insufficient insulation. I need, R39. There's this window reflectivity. It's going to cause problems for the neighbors. And I've got a reference. And so, I've deliberately not put everything that BCF has today, but just to show that we could put this here, and clash number one. So, in this case, you've got your issue tracker, and you just say, either you say export open issues as IFC and you bring it into your model, or if there's a streaming model where you're able to just stream in IFC format from an API endpoint, you can, in your model, your issues are right there, right? And within that, you can potentially have views of the model. So you're in the issue and you click and you just, within that same modeling software, going to the view, you can highlight certain things, like, you know, all the features of BCF, and you basically say, oh, it's not a separate data structure. We're just storing that in the model. We're still, the source of truth is still our issue tracker, but then I'm just going to view it natively in my viewer.
Can you open the IFC file?
Yep. Let me open that. That's what I get for cleaning up my folder before presenting. So in this case, we are defining I don't know what this is. This is a def called open issues. It's a node in the tree. And it has just children. Each child has a def with some attributes on it. And so for this example, I didn't go into classes and GUIDs and references and all that. I just did something super simple so that it shows up and gets parsed. This is really all it is. It's just a list of the data that we put in.
The reference field is supposed to be the object and that's the issue.
Correct. Yeah.
These steps could have been also over to that issue, to that object.
Yeah, but you could do an over and add a child issue to that. So that's a discussion for the BCF working group. Do BCFs get tagged to the object, or do they sit somewhere else and refer to an object? Because again, an issue, you know, there's 3 objects related. There's a clash of 3 objects. Which one do I attach it to? Or do I just create a list of issues off on the side, but still in the same data model and refer to everything?
But the interesting thing there is also composition. If
Yeah.
you apply, let's say, the issue to the object, and that object gets like reassembled in 10 different places, depending on how you associate the issue, whether that's, let's say, the path or some sort of thing that's already inherited, that issue also moves along with all the.
Yeah.
So that's
You could do that.
always the additional aspect to keep in mind. There is, let's say, the semantics of what you want to convey, but there is also the composition behavior.
Correct. And then what you could do is do exactly what we've done here and create a list of issues and then do an over with a BCF issue link on every affected object. You add a link to what it is. And if you do that onto a class that gets used 50 times, every single instance says, hey, there is an issue about this model. And this, you know, you've got some modeling issue in your family, so to speak. And that would just flag that everywhere. So, time?
No, I kind of feel these are non-burning issues, so.
Perfect.
Issues. All right, let's move on to next. Thank you, David.
Yeah, let's start with this. So this is something that quite clearly came up that in our use cases we really don't want this silent flattening of opinions based on whoever is strongest. We want to explicitly have the possibility to at least be aware of these conflicts and maybe resolve them manually. So what we did is we have this window 1, and the new thing here is this this little warning sign. So this says opinions, Sam structural, and Walter wrong. And here on the wall we have even an error sign. Opinions, Sam structural are 60, Walter wrong are 120. So how did we accomplish that? Well, so first of all, we have a header now. This is probably not the header you saw from Thiago, but it's still a header. It's probably also not the header that we wrote in the schema, but still it's a header. And
So we have on the base hello wall we have this Ape architect and Sam Structural and Walter Wrong. And so what was the difference between the exclamation mark and the error mark is that in both cases we have two opinions. So in at file rating we have here R30 and here also R30 in the other file. So we have, let's say, redundant data, multiple people saying the same thing. And in the other case, we have one opinion saying R60 and the other opinion saying R120. So that's probably a more severe issue. And that's also reflected in the API. So here we really see the two opinions of, two different opinions. And in the case of the window, we see the agreeing opinions with lesser severity. But now excuse me for a second, because I also want to, how did we do that? Is that like 1 minute of work, 1 hour of work, or 1 day of work? Because that's ultimately what we're testing, right? Is this IFC5 effort that we have now a suitable basis to keep extending? How difficult is that? So these are the changes now that I have in this repository. So yeah, sorry, Leon, I removed your disclaimer, but the header came in place of that. And then we get to the viewer code. There's a couple of changes throughout the code base, because I will show you that here. In our flatten attribute function, instead of just having a naked value for all our attributes, we actually get an object that says, value and opinions. And this opinion just starts with just a single opinion. And then our composition function also changes only minimally, where previously we could depend on the JavaScript spread operators. I'm not sure if you've been following this new JavaScript development, so it's not so new. But basically, yeah, previously it was 3 lines of code. Now it's 10 lines of code, because we pack basically that what was previously a naked value, we pack that into an object. And when we do composition, we concatenate the opinions. And that's it. So yeah, that's really just, well, I don't type that fast, so it wasn't 1 minute of work, but it also wasn't an hour. I think that's really nice that you can, based on this, really quickly deliver quite compelling use cases. Questions? David?
How much extra work do you think would be to create a list of all the redundant issues and the conflicting issues?
Well, not 1 minute, but no, that's so currently the implementation is not so efficient in this viewer. It's not lazy. It's just you compose and then you do a full traversal. So it's just capturing these kind of yeah. Okay.
Thank you.
Okay, so fancy intro at the beginning. We were working on the code generation because we were a team where we had a TypeScript guy, Java guy, and C# guy, and also Java from Helga. Okay, so I really liked how Tom presented yesterday the idea about the type spec, that there will be the one schema, and based on that, all of different clients, different languages can generate their own code automatically. And that is really good idea, because starting with the type spec, we can go to the Open API, and then with some free open source tooling, we can generate a lot of different versions of the client code. So there is plenty of tools which can be used, which we don't need to develop. So based on one schema, we can generate a lot of different clients. The idea sounds great. So Based on that, you can get the Java code, C++, Ruby, or whatever you would like. So now you have 5 seconds to check if your favorite language is on that list. Okay, now you know. And, you know, that's very good. But before that hackathon, I tried to deserialize the hello world and other samples from the IFC5. And unfortunately, in the .NET, I was not able to do that, just off the shelf, because of some differences between the TypeScript and strongly typed languages. So I had to create my own code. And as I talked with Pasi, it was also his case. So let's imagine that here is one developer who has created that translation, that deserialization by hand. And then there is the other developer, and other. And you get the point. We are not using what TypeSpec is giving us. So we just sit down and take a look what can be changed without disturbing changes. And there is the inbuilt features, which is named discriminator. And we already had it for the class, over, and def. Because as you can see with those arrows pointing to the def name, it specifies, okay, so what type of object it is. But what was missing was just a very small discriminator in the type spec. So very easy change without disturbing already existing files. And after the change, I was able to deserialize IFC5 without extra effort. I was just using the open source toolkit to generate client class, and voila, it is there. So the entry level was decreased significantly. But there is still one more thing to do to make that traversal very easy. Those are the components. Because currently the components, they are distinguished by the key. And the idea behind the discriminator is that the feature, that the property, which is used to, okay, so are we dealing with the IFC5 class component or with the USD shade? It should be as a value, not a key. This is very nuanced difference, but it will make the life for those guys coming from the strongly typed languages much easier. So this is something which we hope that will be changed in the next version of the schema. And based on that, the traversal between the type spec to other languages will be just very fast pace. But still, more work has to be done in terms of the schema, because in JavaScript you can type any unknown whatever, you know. I really love that language, but in the strongly typed, it makes just a nightmare. So that's all from the code generation side. Thank you.
We have a Miro board with snippets from IFCX. And we started with the hello world example. Actually, I think I can. Yes. So we started with the hello world example that you know from the course. And in there, if you zoom in, there is already an example of how properties can be assigned to elements. In this case, isExternal property is assigned to a typical window type class. And in this case, the only thing we had was that isExternal has a value 1, and it's coming in this IFC5 properties container. And we tried to analyze what are the needs of the industry, what are the things that we are used to in the software. And of course, this was just a very simple example, but then we tried to dissect it into all of the small problems that we have and try to find the answer. We started with units. You guessed right, Leon. It was the simplest yet the most complex topic. And we started with very optimistic approach that everything can be SI unit, and that's it. We are done. And everything could be defined with those 7 official dimensions, like length, mass, time, and all of the units could be derived from this, and everybody knew that they are in SI units. And at some point we also discussed, what about like a display unit? Should we define it in the IFCX file, or should it be just on the software side? And we agreed we don't have to put that in IFCX. It's enough that we know that everything in IFCX is SI unit of certain dimension. That was when we opened many let's say, problems, such as, yeah, is it sufficient for every cases? And we knew it's not, because there are many things that don't fit into this simple category. One of them was decibels. We discussed also productivity measures, such as piece per minute, or environmental properties, such as equivalence of CO2 greenhouse gas emissions in kilograms, and all of those things that couldn't be derived from the 7 dimensions. And we, yeah, at some point thought, okay, let's have 80% covered by the dimension and maybe 20% covered by custom units. That was our, yeah, let's say, solution that we had for half of the day. And yeah, we already had some ideas how this could be done, but then we realized that it's basically coming back to the measure idea that we have in IFC right now, but we should definitely simplify it so that we don't allow alternative units for every measure, and we have a fixed list of measures. And one of the ideas that we came up with was to have a list of measures that have always, yeah, fixed SI units, or the units that are the most popular. It's not the end. And then we discussed how do you, once you already agree on the measure and unit, how do you define it in IFCX file? There are many, many options. One of them was to define it every time you assign a property to an object, or externally in a system like, I don't know, IFC documentation, BSDD, Autodesk parameter service, or somewhere else. And another option was to define it in IFCX file and reference every time you add it to an object. At this point, don't pay attention to the identifiers like GUIDs, URIs. We decided this is out of the scope of this group. So, and this is the idea that we try to replicate in IFCX example. So in the top container, you see 3 properties assigned to an object. In this case, those properties are is external, file rating, and net volume. And to know what is the meaning, what is the name of each of those, you need to find property definitions that define that. This one stands for is external, it's a Boolean, it could have a definition, and so on. You could have a string value that has an enumeration of possible values, and yeah, there are many other possibilities. And then one of us did write like a bigger list of all of the possibilities. Of course, we haven't really decided, are all of those needed? Do we need, do we need to limit that? But yeah, in this example, we, for example, have custom property that has different display name than the code, and it has a data type and the dimension and a measure. And the measure, yeah, we also analyzed if it could be a separate object, or does it have to be defined by the standard, or can it be also a custom measure? I don't think we reached any conclusion on this one. Maybe you want to, because yeah, you are.
Yeah. Is it on? Yeah. Oh, very on. Yeah, I don't think we necessarily reached a conclusion, but I think we agreed that we definitely want some common definitions, and potentially the ability to have custom definitions for the 1% case later. Otherwise, we'd have to say this is stored generically, and let's work with buildingSMART and get it into the standard, and then a year from now we can use it. So I don't think we finalized that, but those are the options.
Yeah, and this refers to both the property. So for example, here we have a net volume property, and the measures that describe what this property is, whether it's a length, or in this case, this is the length to the dimension of 3. So this is like the volume, and those measures could be reused in the file. We also compared with other proposals, for example, like the one that Autodesk is using internally, which is very similar but different. we tried to discuss what do we do with empty values. Should we have a official? We didn't reach conclusion on this one as well. Just going through this. That's exactly the example with measures. So we already talked about this one. We also started another topic, which is, do we need to group properties or not? And we didn't spend much time on this, but I think the conclusion was, let's try to avoid it if possible. And the only thing we need for now is to distinguish where is the source of the property, whether it's official IFC or NLSFB or any other standard, or is it my company standard? So very similar to how BSDD is right now dealing with the grouping. And one of the options that we still left open was maybe have some sort of tag if software wants to group it to display it visually, but definitely not as a required thing. So in some way we are like breaking with the concept of property sets that are required if you want to assign property to an object.
Yeah, and the last one I think is still, we're going to need to get some feedback on that.
The kinds?
The property sets.
Right. But yeah, when it comes to kinds, so whether we should continue having complex and tables and so on, so far we decided let's try to limit to single and arrays, so single and lists, and everything else we don't cover in IFC 5. But still, yeah, I think with lists we could cover most of the cases that we found. So that was the answer to the global warming potential challenge. That we will just stick with the simple list values.
No tables.
No tables.
No.
Still, yeah, it's only a standard if we have support in the software. So let's start with simple thing that can be.
But did you conclude that you also don't need tables for your global warming use case?
We discussed that this can be solved with just lists, as long as the industry agrees on one way to use that list. But I think this is possible to be solved.
I also, by the way, I also don't think that a single property should be the solution to every problem, right? If we have carbon issues, we should consider, is there some component that is a group of properties that are well-defined and common that we should use to solve this problem, as opposed to some arbitrary property, which is a table of tables, blah, 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 that maybe the reason we use the table is because we haven't defined it, right? So, and if it has to be a table, then version 1.2 can add a table.
Just on the subject of tables, in like structural engineering use cases, you run an analysis, you get massive tables of data. I don't really want to put that in my BIM model because it's an order of magnitude bigger, right? And so there's, if you do need a big voluminous table, maybe it's just the identities, the goods or the namespaces or whatever. The table will refer into that, so that a reader can read the table and associate them, and use just the naming from that. But then it's
But then where's the limit? If you have 3x3 table, do you put it in? And if it's 10x10, you put it outside of IFCX, or?
Well, without starting a can of worms, I'm not interested in doing that now, right? We don't have to store everything directly in IFCX. It could be that the property is the name of the text file that has a table, right? And you know that, okay, this property, I'm going to go read this table, and it's in this format, and that's that.
Right. And that's, Thomas? Yes.
So also keep in mind that the IFC table property is specifically a lookup table. So it's a table with, at most 2 rows or 2 columns, depending on how you do that. There is also the reference property to an IFC table, but I think that is not being used. And my point is, that kind of lookup table could also be 2 separate list properties. If you can't define, if you can't agree on, let's say, call it A1, A2, A3, then you exchange it as a separate property and the values in another property. You just have two synchronous lists, basically.
As separate properties or in one property?
Separate properties.
Yeah.
And my other point was for the measures. Did you consider the ugliest solution to just embed that in the property name? Like something volume, something length.
Strings are horrible. I mean, just to use them, because of course then it's, well, of course you're stuck with English, right? And
yeah, but any list of measures would anyway be English, right?
you can parse the name, but you can also just put it somewhere, right?
Yeah, well, but it seems like we are moving from a single value to quite an extensive object, and so
But you do it also once in a file, and you can reference it.
yeah, but then still
hundreds.
you have the value and the reference to that, right? So still you need to blow that up.
Let's discuss over the break, right?
Yeah. You wanted to add?
At the end, we were discussing like single value, list value, and where is the limit. And when we went forward and said, well, there is a string type which can express everything actually. So if we want to do extensions or whatever, they can be still expressed. So that's where we come like, okay, let's limit there. And then it can be interpreted anyway. We want to encode the table or whatever data you want, you can encode in a string.
Right, and yeah, we can consider extensions, but at this stage we just want to stop somewhere.
That's a good, nice bridge. Any burning questions? Thank you. Who was next?
Thank you.
Hello, I'm Massimiliano from Sierrasoft. And in our group, we discuss about the linear placement. And the discussion started where if linear placement is necessary or not. We think it's not necessary like a system to placement, but is necessary for system to referencing an element to an axis. And in our job, we define a possible structure to use the alignment and we create a new object to connect the data in to the alignment also. In this part is the standard structure of facility infrastructure structure like project, site, raid, or roads. And inside the roads, we insert the definition of the connection, definition like a connection to the class alignment. And also inside the road, there is for this example, a definition for a sign along the alignment. This sign is defined by his class, and with his class inside the class of the signal, we find the representation of the signal, the transformation that is the primary placement of the signal, like the EFSE local placement before, and the second we add a linear reference. That this is the secondary placement of the signal is more similar to linear placement. This define is connected to his class. This class is we call linear reference, and in this class is more similar are EFSE point by distance expression. In this class you can put by attributes the distance along the axis, the offset lateral, the offset vertical, and the offset longitudinal inside this element. And this class is also defined inside the alignment, in this way, in this way, in this way we can connect the reference to his alignment. With the distractor, we have a different way to read the data of the infrastructure facility. Because for a viewer, for example, you can read only the basic structure. In this way, here you have the complete representation of the axis, of the road, of the rail. If you have a software like us for design roads, you can read the representation of the element, and you can read the alignment connected to the road. Because this is very important for us to redesign, to analyze the road. And if you need a third system to check the position of the element from the alignment, you can read all data, and with this you can create calculate the new position of the element exactly from the axis. This solution is similar to linear placement, but is not necessary. Okay, in this way, it is not necessary the other software implement all function to view correctly the element inside the project. Decide in which level read the data and which data they need for the purpose. Okay, we try to write an example. Here we write an NFC example of the element, and we can show it in the viewer, and it's work at the moment. It was okay. This is our purpose. In the geometry, resolve the position. The visualization is primarily is used by the normal positioning. This is the first. But if you, a software, want use this information, can recalculate the position by the alignment. But is the software that read the IFC decide, okay, I use the fixed, the local placing, or I use my positioning using the information from the linear reference. The software decide which information to use. In this way, different from linear placement, the local placement must be inside the software, inside the IFC. This is the main difference. In this way, the other software, like a viewer, don't need manage an alignment, manage a linear placement, manage many things, but they can view the result of the content inside the IFC. The transformation is the correct position from the road, from the site, from the yes. Yes, yes, like a window.
Yeah, that was our question. This
Mm-hmm. Yes.
Can, if they want to, also do the alignment calculation.
Yes, and check if it's correct, because you have two values, and you check if your calculation is correct. Then the software has create IFC.
what happens if you
instance is, in this case, is a mesh. Is the representation of the object you can have or don't have. For stationing example, you don't have a representation. You have only the information. See, yes, it is normal. Like the example of the Windows with that body with the mesh and the transformation to put in the correct position in the space.
Right, but for the window example, right, the Windows transformation is relative to the wall, which is relative to the level.
Yes. Yes, this work in the same way because IFC5 work in this way, I think. Okay. Okay.
Thank you again.
Okay, so the topic we covered in extent with quite some confusion about terminology, etc., was geolocation in IFC5, in IFC in general as well. So the whole reason that you want to geolocate stuff is so that multiple models from different places on Earth, you can put them in the same context. So, in order to do this, you need to take, for example, your BIM model, and you need to make sure that the coordinate reference system that you use in your BIM model knows how it is located on Earth and with what rotation and so on. So, there's actually multiple spatial reference systems. There are spatial reference systems that are registered with the EPSG, and most of the ones we use, they are projected coordinate reference systems with an EPSG code. And then for certain infrastructure projects, they define custom CRSs to design an alignment, for example, and then there are coordinate reference systems that are not yet geolocated inside design software, analysis software, and then this coordinate system that the BIM software uses needs to be georeferenced. And the way that you georeference these coordinate reference systems is by using a survey point. And what we propose is that in order to make sure that, for example, my geotechnical data, which is in world coordinates with easting, northing, and an EPSG coordinate reference system, can go into the coordinate reference system of my BIM model, or my BIM model can go into the coordinate reference system of my real-world coordinates. In order to create these transformations, what you need is a WKT string. This is a standardized and OGC standard for defining spatial reference systems. So, yeah, then we go to the proposal already? Or, okay.
Maybe first, like some more context. So yeah, the difficulty around this whole topic. So there was quite some discussion. We almost missed our lunch today. So the difficulty with this topic is always like you have two worlds, the BIM world and then the GIS world. And somehow they have to collaborate. And also in even purely BIM workflows, you want to somehow use some GIS data like georeferencing. So there's like different types of data sources that you can have. So you can have geodata, I call it now. So it's data which is fully georeferenced. So basically, like your whole data set, each and every data point is actually has geo coordinates. So it could be, for example, a terrain model or something. Then you have models that are modeled in just a Cartesian 3D engineering coordinate system, but where you want to add georeferencing to. For example, depending on the scale, whether it's a building or an infrastructure project, it might be one or multiple survey points. And but then, of course, you have the pure local workflow where you have models that don't have any georeferencing, where you just want to put, for example, let's say you have an architectural model, you have an MEP model. They both don't have geo reference, but you still want to coordinate them. You want to be able to put them together that they're nicely aligned. And so there's kind of different levels of georeferencing. So what we aim for is to have like one unambiguous workflow where you can, for all these cases, federate or put different data sources together.
Yeah. Excuse me. Yes, indeed. And so there's different types of spatial reference systems, ones that are registered, and then spatial reference systems that you need to create to georeference a model space from design or analysis software. So these objects, you can then, we propose that these georeferenced coordinate reference systems live in the root of the like IFC 5, and then, for example, this projected coordinate reference system is used by the site, and then everything underneath site uses this coordinate reference system, except for some models that are created in design software or analysis software, because then for those you create a spatial reference system based on a survey point, and then you can assign those to other hierarchies. So, for example, if you have the tunnel might not be the best example ever, but maybe you have a tunnel entrance, a BIM model of the tunnel entrance, and that has been modeled in Revit or whatever. So you export it, and then the geometry has some coordinates, 0, 0, somewhere in the middle left corner, and then you georeference it by creating this CRS for that thing specifically, and you create a WKT string for that georeferenced coordinate reference system. So if you want to look at the code, there's objects that define using just the standards, like WKT is this standard, right, from OGC. This would be an object for a registered CRS, and then how exactly this object is going to look is not exactly clear yet, but it could be something like this, that you say, okay, the WKT that allows us to calculate these transformations between this coordinate reference system and the coordinate reference system of my BIM model has, you need the WKT strings to calculate these transformations, and this WKT string is informed by this survey point. And then these things, you assign them with a def over to the object that a CRS applies to. That is the proposal.
Maybe to make So maybe because it's quite a complex matter. So to indicate our proposal, let's look at like kind of the differences between IFC 4x3 and what we are proposing. So one of the things that we want to do is to allow to add this georeference as an over, because often the person creating a certain BIM model, for example, will not be the person who provides the georeferencing. So we want to now the BIM modeler would need to add the georeference in his BIM model and export it to IFC to have it included. We want to allow that you can just overlay it as two separate IFC 5 layers. But in order to do that, we need to limit a bit what you can do in IFC. And so now this georeferencing would be attached to a certain level in your composition. So for example, on a site level or on a building level, you would attach the georeferencing there. Whereas IFC 4x3 now allows to define different geometrical subcontexts, which have each their own georeferencing. And so within one building, you could have data that refers to one CRS and data that refers to another one. That would not be allowed anymore because we say on a building level, hey, that's the georeferencing for the building. Was that a bit clear? So that's one change. And then, yeah, the definition as a WKT string is a change. Yeah, multiple survey points actually is kind of possible, but not yet that easy. So we'll probably have to modify that as well. So that's kind of the changes with IFC 4x3, and of course then the JSON format.
I think this is really great. Say you had two buildings, would you allow a CRS for each building within one model?
I think that should be possible. Yeah. So yeah.
In that case, they're both in a tree from a site. There may be transforms between them as well. Would you, if there was a disagreement, so like for the alignments, right? The primary was the relative placement, and then the linear was sort of a secondary one. Here you'd have the CRS. You'd also have potentially have a placement tree. Would you just forbid that? If there's two buildings with two CRSs, there can't be any transforms in the parents? Or would you say that basically, if you hit a CRS, you reset the transform? Or
so the transformation depends on from what to what.
correct.
So the CRS object just informs you on where on Earth it is and how it is rotated, etc.
Would you ever see a situation where you had one CRS for, or one CRS thing for the project, and then one for each building underneath?
Yeah, I think that can be possible, right? If you as I understood, right, if you have a very long project, then the alignment is going to be in some EPSG registered CRS, and then models along this alignment, they're going to be modeled in Revit or whatever, and then those sections like the tunnel entrance, tunnel linings, then maybe some bridge even further, they are going to have different coordinate reference systems, each of them. And then the transformation, but you can calculate because you're using these WKT strings and there's software that can calculate the transformation, but the question is always from what to what.
So in a sense, if I've got a BIM software, I'm just going to read it in and ignore that because I can't deal with that, and I'll have the relative placement. But then GIS software reading it as it goes down the tree, whenever it hits a CRS, it can throw away any previous stuff and restart, and then calculate itself between the various.
You can see like the georeferencing as the over of the like flat X transform between, for example, a project and a building. And so, for example, a BIM modeler, he doesn't know yet the georeferencing, so he exports, and from project to site to building might just be like unitary transformations, but then the surveyor adds an over to that, which is not just another X transform, but which is kind of, let's call it an advanced X transform, which actually uses this, georeference transformation.
You're satisfied, right?
I have one quick question.
Quick? Burning, quick.
Oh,
yeah.
I was wondering if you ended up punching or thinking about, I mean, I gather with CRS, right, that also affects how you look at the Cartesian points themselves, right, because they could bend. And architectural software is flat earth, you know, we don't believe in round things, but civil. So did you just punt on that, and it's up to you to decide whether to transform things, or did you decide to do something else about it?
Yeah, so if you want, you can take a BIM model and then transform all the mesh vertices to some EPSG registered projected coordinate reference system, right? And then you would attach a CRS object that is an EPSG registered CRS object. So you can indeed do that. You can say, okay, we have a BIM model in our engineering coordinate reference system, and we geolocate that by attaching a geolocated CRS object for the engineering coordinate reference system. Or if you wish, you can transform the whole model into the coordinates, easting, northing, elevation coordinates of some EPSG registered coordinate reference system. And then you would attach such a CRS object to that geometry.
Sorry. Units. Oh, definitely not units. More questions in the break. Thank you.